Hi there, and welcome to another chapter of the electric BMW 320i project. Well, I was hoping in this video I was going to be able to show you the car running, but unfortunately it's still not. In fact, the motor is still not in the engine bay. Here's a picture of it. I hope that that's going to go in pretty soon, but for this video I'm going to show you some of the struggles I've had with the 12-volt wiring. It's almost like making a whole new wiring harness for this, as well as some of the preparation I did for the JevQ and the BMS boards. So let's take a look. Here the rear seat battery boxes are all ready to go. Got some nice 3/8 inch plexi to cover everything up. Thought it would be a little bit cheaper and easier to use than aluminum, and then also you can makes a nice display. Although I'm probably going to try and put the rear seat on top of this. I'll have to cut out a bunch of springs or something to make it fit, but this works well. And then having the fuse in the middle of the pack here is good, and just 2 screws to get that open, but keeps everything nice and isolated. So the next thing is trying to see if the rear seat will fit over all this stuff. Here's the primary contactor box, and one of the things I found out when I was fitting up everything was that this hole on the side where the battery cable came out hit the bottom of the battery box. So I'm going to have to move the hole over, which I'm going to do is got another piece of this plastic I cut out and just glue it on there and drill a hole, and it should be all set. Okay, 24 hours later, and the new piece of plastic's well stuck, so here we go. I'm going to try and drill that hole out. And the surgery was a success. Now, new hole for the gland nut. Offset just enough so it should fit inside and clear the battery box bottom. Here I have the vacuum pump installed. That's for the vacuum assist power braking. See quite a collection of stuff. There's a check valve, and then a pressure switch, the sensitive switch that turns the pump on and off. There's also got to be a reservoir for buffering the vacuum, because the pump just doesn't have enough flow when you put on the brakes, so you have a big canister. But quite a mess of wiring, the relay and a connection to turn it on and off the power. It just really is looks like an ugly way to go. And then on top of that, well, started out all these fittings are 3/8, but then this fitting that goes on the BMW is 1/2 inch. It's actually 12 millimeter. So I gotta at least do this last bit of hose over again, because this is not going to work. Not going to go into that fitting. It's got to be a better way to do this. Here's what the canister looks like, the reservoir, when it's on a bracket and held up there. So have to have a T on the line to come out, and one line come here, one go into the power assist unit. I thought while I still had the motor out and demock, I'd finish up all the wiring, because it's still a lot easier to stand inside the engine bay and do all this wiring. I have now all the high voltage cables, high current cables for everything, the bus bar and a disconnect, and then this is my main contactor box, which I've shown before. One of the issues with this contactor box, it's great, you know, this little box you can see stuff pretty well, but one of the problems is if you don't have enough distance between a contactor and the gland nut for a cable to take up some difference. The height of these is too tall for the side of the box. So what I had to do in this case is make up a copper plate with a little bend in it to take up the offset, so you can come through the side and be able to make contact to the contactor. So, and even between I have a strap too. So this is the pre-charge contactor, and then the main contactor, and then the main contactor for the low side. And on top, this nest of wires is all the control signals for those relays, and most of those are going to go to the DMOC. And that's going to be the last thing probably I'm going to do, is I'm going to put the hood back on and measure what my inside clearance is, so I can determine if I actually can put the DMOC on top of the or the JevQ on top of the DMOC and wire it up that way. That would be very convenient, but I don't know what kind of clearance I have with the hood, so we're going to test that out a little bit later. One thing I noticed when I was testing out this contactor box with the JevQ was when I turned on the 12 volts initially, before I had programmed the JevQ for the particular program, I heard the contactors actuate. You can hear it there, a double click. Well, the first click is actually not supposed to be there, and if you look at the oscilloscope over here, the top blue trace is the output from the MOSFET, the bottom is the actual voltage across the contactor, which shows the contactor closed. And this is a problem because what's happening is at the beginning of the startup of the Cortex processor, it's setting the outputs to a high level, and that's causing the output of the MOSFET to turn on, which then causes a cascade to turn every one of these relays on, and that's not a good thing, because this is designed to only have at the beginning this 250 ohms into the DMOC, and if this contactor shorts, which it does for actually a pretty significant amount of time, about 30 milliseconds, that's enough to pulse a big current through that and probably fuse the contacts. So this is something that we've figured out is due to the fact we don't have a pull-up resistor or pull-down resistor on the output of the actual Cortex processor. That's where the problem is. We have pull-downs on the MOSFETs, but that's more for an ESD control. And here I'll show you a picture where I've actually soldered on a couple of pull-down resistors and then tied them directly to the lines on the Cortex processor, and I'll run this again and show you that there's no actuation except what's supposed to be there. Here I've connected up that JevQ that has the pull-down resistors, and when I turn on the 12 volt power supply, you just hear the one actuation, and then 10 seconds later there'll be a second actuation, which is actually the timeout for the pre-charge. There it goes, and if you look at the scope, that's exactly what it's supposed to do. There should be no transient. That's the timeout that's designed there for once the JevQ is all the way up, then it sets the output to the right value and closes the main contactor so that the pre-charge resistor is in the circuit and charges up the DMOC. So it's something we'll have to fix on future versions of the JevQ board. The other last thing about this contactor box is this CAB300 flux gate sensor for measuring current. Both ways I'm going to be measuring current, just to see how things work out. But this mounted up nice and tight, and then just got to get another gland nut to bring these wires through for power in the CAN bus. That should work out really well too. Here's how I make up these amp seal feed-throughs. This amp seal connector is normally designed to solder right to a circuit board, but I'm not really going to make a circuit board up, and plus I need wires. So what I do is I take a normal just regular amp seal and crimp pin and crimp it to a wire, and then slide it over the pins, and then go back in and put some solder on it. And then once the solder is cooled and all the wires are cooled, then I slip some heat shrink over it like that, and heat shrink it on, and so it provides a nice strain relief as well as an isolation between all the wires. Alright, the wiring junction box is done, and this is basically designed to take the signals coming from the JevQ and distribute them to another connector that goes to the throttle and brake, and then goes to the contactor box to actuate the relays for the contactors. And it all checks out, all the right wires in the right place. So next thing to do is make up the amp seals that go make these and be ready to install. Testing out my latching relay system for the ignition, which will turn on the main contactors for the high voltage. It's shown in this schematic here. Basically, the going to use the regular key switch on the console and the momentary contact, which was the starter switch, which will energize a relay, and then that feeds back on itself through the slap switch and an inertia switch to make a latch circuit. And so when any of those circuits open, it should open up the relay. So closing this, see, we get circuits on, and now the momentary contact collapses the circuit. So that should work really well. One relay to control everything. Next thing to do is get it in the car. Alright, starting to build the final wiring harness for everything. We have the main contactor box and these cables coming out. These all go to the fuse box, and these all go on an amp seal connector to go into my wire connection box, and then that eventually connects out to the JEV cube, and this is for connection to the throttle and brake. So just have to put all the amp seal connectors on these, and it should be all ready to put back in the car and ready to go. Here's the wire crossover box all connected up and installed. Unfortunately, it's gonna interfere with where I was going to put the maintenance switch. That round circle cut in the plexi was the mounting place for the maintenance switch, and that's just not going to work. It was bad enough that this cable was going to have a big loop to clear it. So I really wanted to put it up on top, but the problem was it wouldn't really fit under the hood at that level. So I just bit the bullet and moved the bus bars down an inch, so this whole plexi assembly can move down an inch and make room for that switch on top. So this is how the maintenance switch will sit, and it's definitely now not much more higher than even the fuse box, so it definitely will clear the hood, and it'd be a good place, nice right on top, to be able to get a hold of it. Although again, it's just for maintenance, not really for emergency purposes. Problem is, now I'm going to have another plexiglass pieces cut to put that in that position and build up another isolation around the bus bars, but it does look like it's going to work just fine. Always more work. One other thing I got installed was this new CVR vacuum pump for the power brake assist. It's a great little unit. It's got the vacuum switch and the relay all built into it, so all you have to do is apply power to it, and it will run and automatically turn off when it hits. Right now it's hitting about 18 inches. I'm going to try and adjust that up to 20. And then that's the that chrome cylinder is the reservoir for the vacuum, and then that connects to the power brakes. That's not all connected up. I've connected it just to test it, leak test it, but that's going to have to come out because that might interfere. You can see it. It doesn't. The motor won't interfere with it, but the motor going in might. So I'll just take all that out when I put the motor in. But it's a really nice little pump, and it's a lot bigger than what I was going to use, but It's just a lot easier, no extra wires, just one set of wires coming up to power, and that probably will be it's connected just to when the DC-DC converter comes up, that will turn that vacuum pump on. Here I have my JFQ and BMS board ready to be conformal coated. This is the material. Provides a nice seal on all the electronics so that if there's any moisture at all, even though the cinch connector and cinch enclosure should do a really good job at sealing them up, there's still always going to be some moisture somewhere. And so almost every electronics I've ever seen that gone into automobile always gets this kind of conformal coating. So we do 3 or 4 coats, get up a nice layer, and let it dry. It does pretty good. Comes out, it dries about 5-6 minutes after being applied. Alright, now they're all nicely coated. As you can see in the get a reflection, you can see that shine on there. It's a nice conformal coating. Not quite as nice as what you get professionally, but out of a spray can that's not too bad. That should protect some of the circuitry better than if it wasn't there. And you know, I had to put all the tape on there to protect everything you don't want, especially the seal for the cinch connector, as well as the USB, and one little thing here too, the antenna pickup for the Wi-Fi. But yeah, well, that's one last thing that had to be done. Here's the boards now. The conformal coating finally all cured. You can see they have a nice sheen to them. That's I don't know, they say probably about 500 microns or half a millimeter thick coating is sufficient, so shouldn't be better than nothing at all. But that's the last treatment. The only thing left on the JFQ is to plug the antenna in for the Wi-Fi, a little patch antenna I got, and then they'll be ready to be put in the cinch enclosures. Testing the Wi-Fi before I put this all together, I discovered that this patch antenna that I got, which seemed to work pretty well before, now doesn't work with the conformal coating, probably because patch antennas usually need a ground plane to work, and now I got a nice dielectric layer over the ground plane, which is the top metallization on the board. I even tried a different style, and this one didn't work much better, so I had to go back to the old dipole antenna on the outside. And well, that works very reliably to connect to the computer. These worked, but they weren't very reliable, and then sometimes it would connect and sometimes it wouldn't, and sometimes it connect and then the website wouldn't come up. So this works really reliably. I just have a SMA feed through here. Probably will remove the antenna after I program the JFQ or whenever I want to use it, because it really doesn't need to be there, and then just cap that off with some weather tight cap. But that's all working now. Put a little bit of silicone on there to strain relief and also keep the cable from flopping around. Next thing is to put it in the car. Well, there you see, it's quite a lot of wiring going on. You know, the 12-volt wiring is just like doing a whole new wiring harness. There's 12 new circuits, and that's a lot of wires. You know, the high voltage wire is pretty simple compared to that. So now that's all done. The last thing to do is to get that plexiglass parts put together so that isolation switch can be mounted on the box, and then get the motor back in and make all the final connections. So it really is my goal that I mean, I'm probably definitely going to have, the next time I do a video, you see a video, it's going to be driving that car. So thanks again for watching, and wish me luck for the next time you see me. Bye.